The following animation will present a case study on the use of rhythmic run detection and display, graphical seizure review, and the use of seizure prints. As we explore the use of rhythmic run detection and display, we will include a comparison with FFT spectrograms as well as traditional event-based seizure review. This presentation should be viewed after watching the video overview of rhythmic run detection and display, also known as R2-D2. At any time during the presentation, use the pause button on the QuickTime player to stop and view any slide in detail. You can navigate anywhere within the presentation by using the progress slider, located at the bottom of the player window. Select the play button to resume the presentation. Every neurologist knows that seizures are usually accompanied by rhythmic EEG patterns that evolve in frequency and spatial extent over time. This seizure example is displayed over 90 seconds of EEG in a double distance montage. The pages are displayed from left to right in 3 rows. This 90-second display allows us to follow the seizure throughout its course of evolution. This left temporal seizure is evidenced by a change in the predominant frequencies and their amplitude from the onset to the offset of the seizure. FFT power trends and spectrograms offer poor time versus frequency resolution, and they tend to obscure rhythmic activity. This slide shows a traditional spectrogram at the top versus an R2-D2 trend at the bottom. Both are displaying EEG over the same time frame. The FFT calculation has an inherent trade-off between frequency and time resolution. This means that, with FFT spectrograms, something has to give. The result is low frequency and time resolution. This means that there isn't sufficient detail to recognize seizure activity with any degree of certainty. Rhythmic run detection and display does not suffer the limitations of the FFT spectrogram. The high-resolution R2-D2 display shows only what is rhythmic or periodic in the EEG. Here, shape and duration indicate frequency evolution. Individual frequency components can be seen as horizontal bands in the trend as the seizures evolve. This detail is completely lost in the FFT spectrogram. FFT spectrograms and power trends often don't do a very good job of trending anything but the most obvious seizure activity, and frequently provide poor distinction between seizures and artifact. In the example that follows, we will compare the display of seizure activity versus artifact. We will use an FFT trend of 6 to 14 Hz power, an FFT spectrogram, and the R2-D2 trend. Here, seizure prints that exhibit both shape and duration, in other words evolution, are marked in red. The first seizure print appears in the bottom R2-D2 right hemisphere trend. The underlying EEG at this point confirms the presence of a right-sided seizure. The next series of seizure prints appears in the top R2-D2 left hemisphere trend. The underlying EEG at this point confirms the presence of a left-sided seizure. The marks at the far left exhibit little to no change in shape or duration. These are caused by artifact as confirmed by the underlying EEG. Let's compare the R2-D2 trend at the top with an FFT 6 to 14 Hz power trend. While there are deflections in the power trend for seizure and artifact alike, there is no way to differentiate or identify seizures or artifact activity from the power trend. Note that power ratio trends will fare no better in this respect. Next, let's compare the R2-D2 trend at the top with the traditional FFT spectrogram. Again, there are deflections for seizure and artifact alike. However, there is no way to differentiate or identify seizure or artifact on the basis of the FFT spectrogram display. In both cases, FFT-based trends do not provide sufficient detail or discrimination for seizure recognition or review. Event-based seizure detectors mark points of interest in the underlying EEG, but they don't provide a global high-level overview of a seizure's morphology, predominant frequency, or localization over time. This page of EEG is accompanied by a list of seizure detections. Traditional seizure review requires the reader to move down the list of seizure detections and examine the associated EEG traces to determine the presence of an electrographic seizure. The list of rhythmic burst events in the comment list indicates frequent right-sided seizures. Their morphology, spatial distribution, and temporal distribution is not easily discernible from a traditional list of seizure detection events. We can glean more information about the morphology and frequency of the seizure activity from the R2D2 trend. There are 9 seizures in this 2-hour trend display. Seizures have marked right-sided rhythmic alpha and intermixed evolving delta plus beta. Several seizures spread to the left.